Greetings. Our research work is entitled Towards Recycling and Promoting Sustainable Nature-Based Solution for Stormwater Capture Using Pervious Pavement. Nature-based solutions for stormwater collection are sustainable ways to manage water while enhancing ecosystems and reducing flood risk. These solutions work with natural processes rather than against them, offering multiple environmental and societal benefits. NBS approaches include green roofs, permeable or pervious pavement, rain gardens, bioswales, constructed wetlands, and urban forests primarily. The aim of the research work was to develop a sustainable solution that addresses the environmental issue of plastic waste and the increasing frequency of floods in Mauritius. Towards this aim, the three objectives have been defined. First, to incorporate waste plastic in the form of HDPE, high-density polyethylene, into an open-graded asphalt mix. Second, to produce porous asphalt capable of allowing water infiltration. And third, to explore the dual benefits of reducing plastic waste and improving flood management. The methodology comprised asphalt mix testing, of which specific gravity, Marshall density, Marshall stability and flow, and permeability. Another set of testing comprising those to include the aggregate, moisture content, Los Angeles abrasion, sieve analysis, and the third component, which was to the binder testing, which included tests such as needle penetration and softening point tests on 0%, that is the control mix, 4%, 8%, and 12% of HDPE replacement. So figures 1 and 2 show the porous asphalt specimen that were produced using the 0%, that is the porous virgin aggregates, 4%, 8%, and 12% of HDPE replacement in the binder. Now, the asphalt test mixers produced very good results in terms of the Marshall stability, and especially, as you can see from figure 3, at 4% of HDPE replacement of the binder. And similar observation for the Marshall flow, where we had a minimum value at the 4% for the Marshall flow test result. Now, besides testing the binder and the aggregate as a composite mix, it was important to see how infiltration rate varied when we had the control mix that was selected, and what happened when we had the optimum binder, which was at 4%, and what were the differences in the infiltration rate. And figure 5 shows the setup for the permeability that was devised for the experiment. Now, we could observe that the coefficient of permeability increased as the HDPE varied from 0 through 4 and 8% and decreased at 12% of HDPE replacement. The findings of the study showed that 4% HDPE sample was the optimum mix with a maximum Marshall stability of 13.258 kN, which, as we saw, was adequate as per the specifications for the road material that we have locally. And second, all samples respected the permeability range irrespective of the HDPE content, but the 8% sample had the highest drainage capacity. The cost-benefit analysis was also conducted and showed that there was a 0.63% of reduction in the cost of raw materials. The cost comparison between the traditional and open-graded pervious pavement and that with the 4% HDPE modified pervious pavement led to a slight decrease in cost, as we just mentioned, however, highlighting strongly the environmental advantages of such climate adaptive measures towards stormwater capture. This research aimed at incorporating plastic waste into porous asphalt pavement, which led to a potential in tackling multiple environmental issues simultaneously, for example, reducing plastic waste, improving stormwater and flood management. The objectives included reviewing pervious studies on plastic-modified asphalt to identify the best percentage of polymer blend, investigating also the long-term performance of plastic-reinforced porous asphalt, and exploring the economic feasibility of integrating plastic waste into porous asphalt. This idea could be also projected on a larger scale in the road projects that we have in the island, and alongside it also gives us the opportunity to assess potential regulatory and environmental concerns, ensuring safe use of such products. We now reach to the end of our presentation. I thank you for your kind attention and I welcome any question from the audience.